Dear student, today let's see that the next topic of reactive intermediates. Actually, the reactive intermediates in the chemical reaction, the starting compound that's called reactant. Okay, reactant. It will convert to the product. Product. In between the reactant and the product, that some species are formed. That's called as a intermediate. Okay. So in this video, what are that intermediates are presented, and some particular intermediates only discussed in this video. Okay, so the intermediates, there is a intermediates. The first case is for carbocation, and second carboanion, and the third one that is for free radical, and the fourth one carbene. Okay, so most enough for this four in the NEET and JE. Okay, so and remaining intermediates, there is a fifth nitrines, and sixth is a benzene intermediate. So only this six intermediate are presented in the chemical reaction in the field of organic chemistry. Okay, so generally the intermediate in between the reactant and the product. The chemical reaction has happened during the bond cleavage or that bond formation. Okay, so now we go to that the carbocation, the bond cleavage. First case there is a carbocation and carboanion. Okay, so this is we will study now. In generally, or we can correlate that for carbocation, carbanion, and it's a free radical. Okay, free radicals. Okay, so now the chemical bond cleavage is depend upon. There's a bond cleavage, chemical bond cleavage is depend upon. Cleavage is depends upon. It's a homolytic and also heterolytic. Homolytic bond cleavage and the heterolytic bond cleavage. So depends upon that the whether the formation of intermediate carbocation, carboanion, free radicals like that we can study it. Actually, the nature of the bond here there is a covalent bond. It's a bond nature that is for the covalent bond. The covalent bond already I teached in the previous video. There is only for non-metal and non-metal between the bond formation that is for that covalent bond. Okay, so here there's a organic molecules. So there's a here carbon as the most essential of that element. Carbon one of the non-metal. Okay, if you assume here is a simply representing in the general equation, there is a and B. So this diatomic molecule is for that heterodiatomic molecules. So heterodiatomic molecules. These heterodiatomic molecules always there is a heterolytic bond cleavage, heterolytic bond fission or bond cleavage. Always at a heterolytic bond cleavage. Okay, so in the case of heterolytic bond cleavage, whether they given in the carbocation, or there is a carboanion. Okay, so now this go to that heterolytic bond cleavage. So this completely two electrons taken into this B. So now A will become there is a positive charge and B will become negative charge. Here the electronegativity, which of this is highest, that is must possessing that the two electron. Okay, so or the highest electronegative atom they have must be taken in that the bonded to electron. Okay, so this if you assume here electronegativity B is greater than A, so that's why the B is completely taken in the bonded to electron, it will become there is a negative charge. Here A will become positive charge. Here if you assume A as a carbon containing organic molecules. Okay, containing organic molecules, for that is a carbocation. So similarly B will become what? Yes, there is a carboanion. It's a carboanion. Okay, so in the case of a heterolytic bond cleavage, they have producing carbocation or there is a carboanion. It depends on that the reagent or that the reactant species. Okay, suppose we taken that AA type molecule or there's a BB type molecule. Here A and A as a similar. Okay, so that's why there's a homodiatomic molecules, or anyway there is a molecules, the bond cleavage between the two similar atom. Okay, the molecules the bond cleavage between the two similar atom, that is must be the homolytic bond cleavage. There is always there is a homolytic bond cleavage, bond fission. Okay, there's a bond fission. This is most generally there is always in the photochemical condition or high thermal condition that will give the free radical intermediate. Okay, so now we go to that the bond fission. The homolytic means the bonded to electron. That's for covalent bond. Covalent bond means whatever that they have mutually sharing between these two atoms. So that's for covalent bond. So this shared to electron is a completely reverse of taken is each atom in the single electron. So we can get there is a free radical A dot plus A dot. Here there is a is a similar means there is a 2A dot. Okay, so that's for that free radical formation. If you assume here A as a considered as a carbon containing organic molecules, molecules, that is become the carbo free radical. That is would become for that there is a carbo free radicals. Okay, carbo free radicals. So for this three types of intermediate or due to the formation of bond cleavage, in generally there is a heterolytic bond cleavage. The overall summarize there is a heterolytic bond fission, the formation of carbocation and carboanion. But in the case of there is a homolytic bond fission, that is in the formation of there is a carbo free radical. Okay, so these three is the most essential in the NEET and JEE related problems. Okay, we will go to that detailed explanation now. See this carbocation. For example, in the case of methyl chloride CH3Cl, here the chlorine atom is linked or bonded to the carbon. This carbon is again bonded to 3 hydrogen. Okay, so comparatively this chlorine and carbon, here there is a electronegativity. Chlorine is greater compared to the carbon. We already said the bond between the two atoms, whether the atom is a high electronegative, that will become the negative charge or negative sign. Okay, so this chlorine has the highest electronegative. For that reason, these bonded two electron are completely taken in this chlorine. So this completely taken. Then what will happen here? This electron deficient will become the CH3 plus Cl minus. This is for that there is a methyl carbocation. There is a methyl carbocation. Okay, so the highest electronegative atom part that will become there is a negative sign, and the remaining part of carbon containing organic molecules or there is a carbocation. Okay, see the another one example. There is a CH3, CH and Cl. Here is CH3. Okay, so here this chlorine is attached to this carbon. Here the previous the chlorine is high electronegative compared to that carbon. So that's why this chlorine is taken this 2 electron in presence of reaction medium. It will convert to that CH3, CH plus. There is a CH3. So there is also there is a carbocation. Okay, this also there is a carbocation. See another example. There is a CH3, CH. There is a OH2 plus. There is a CH3. So see here, this oxygen is a high electronegative as well as it's a more leaving group. Whenever that more leaving group attached to that organic compound, they have more readily producing that carbocation. Okay, so this bonded electron will shifted to here. Minus of H2O is removed. Okay, there's a CH3, CH plus. There's a CH3. This also there is a carbocation. Okay, so this carbocation it's a classified in that that's a classification. Actually there is a dependence on that the primary, secondary or number of the carbon substituted, whether that there is a primary, secondary and tertiary. Okay, so we cannot say there is a quaternary carbocation because the carbon of valency has a 4. That is why the primary, secondary, tertiary like that we can classify. There is a and also there is a methyl carbocation. Okay, so first of all the methyl carbocation CH3, there is a X. This X as a halogen. Okay, there is a halogens. This bonded electron is completely taken this halogen. It will become CH3 plus X minus. So there is a methyl carbocation. Already we teach in this video for taken for that methyl chloride. The next category there is a CH3 CH2 Cl or X. Okay, X as a halogen. We can take there is a general representation. This bonded electron is completely taken this X will become there is a CH3 CH2 plus X minus. There is a ethyl cation or ethyl carbocation. This ethyl carbocation actually saying there is a primary in general term of carbocation. There is a primary because of this carbocation the plus charge is containing carbon. It attached as a only one carbon. That's why there is a primary carbocation. Okay, next see that the CH3 CH X CH3. So now this X will remove, that is a X minus. It will become there is a CH3 CH plus the CH3 plus X minus. So now this positive charge or plus charge is containing this carbon. It will attach to that again to carbon. So that's why there's a secondary carbocation. Anyway, the positive charge or carbocation containing carbon, whenever different or depends upon the number of carbon is attached, that is why there is a primary, secondary, tertiary like that. And see the CH3 CX and here CH3. Now this X taken this 2 electron, it will become CH3 C plus CH3 plus X minus. Okay, so see this carbon, it attached 1 2 3 carbon again. That is why there is a tertiary carbocation. Okay, so these all are that is a basic fundamental of carbocation. We will study this next. There is a carbocation actually that is for sp2 hybridization, because the carbon its atomic number 6. What is the configuration? 1s2 2s2 2p2. Okay, so this is a valency cell, valency cell. So this valency cell is participating in the formation of a molecule. That's a valency orbital theory, valence orbital theory. From that, we have simply representing there is a CH3 plus a. Here is a number of the carbon hydrogen bond are presented. There is three types of three carbon hydrogen bond are presented. For each hydrogen as containing one as one, it's a hydrogen of valence cell. Okay, so now there is a s and p orbital. In the case of carbon, there is a s orbital containing there is 2s and there is 2p. Okay, 2s orbital is containing 2 electron and 2p orbital is containing 2 electron. So there is a 2p electron, there is a only 2 electrons or unpaired electron. So the bond formation is needed for that number of unpaired electron. Okay, so it's for that's ground state. We go to that excited state. The 2s electron is energy is gained. It will convert to that excited state. That is why it will give us 4 equal unpaired electron. Okay, so this excited state, there is a hybrid orbital. It will become there is a same energy, energy. Okay, so it bonded with each hydrogen of one unpaired electron. It will become there is a 4 sigma bond. Okay, in this case of this molecule, it's for the formation of methane. Okay, now see, we are studying there is a methyl carbocation formation. In the case of methyl carbocation, there is a CH3 plus a, here carbon hydrogen has a 3 bond. There is a carbon, it has a 1s2, 2s2, 2p2 is a general electronic configuration, but in the case of carbon is a plus charge. So that's why 1 electrons are removed from this electronic configuration. So 1s2, 2s2, 2p1. Okay, so it's a valence cell. There's s orbital, there's a p orbital, 2s, there's a 2p. So s and p. So there's a s, it contains 2 unpaired electron, p it contains the 1 unpaired electron. So it's for the ground state. We go to that excited state. There is a the 2s of electron is, it will convert to that the 2p orbital. Okay, so now there is a 3 unpaired electron. This 3 unpaired electron is making the 3 covalent bond into that hydrogen atom. Okay, so this 3 unpaired electrons, it make it that 3 covalent bond. It is has 1 vacant orbital. Okay, so this hybridization, s is containing 1 and p is containing there is a 2. There is a sp2 hybridization. S is containing 1 and p is containing that remaining 2. That's why there is a sp2 hybridization. So it's sp2 hybridization. There is a 1 vacant p orbital is there. So anyway, the s and p orbital is containing the maximum hybridization as a sp3. But here is a sp2. So that's why there is a 1 p orbitals are empty. Okay, so this sp2 means there is a trigonal planar as a geometry. So trigonal planar as a geometry. So that's why see the carbocation of a methyl, this methyl carbocation, the CH3 plus a, there's a sp2 hybridization, trigonal planar as a geometry. The carbon as a central atom, here is a hydrogen, hydrogen and hydrogen. So this for that trigonal planar and 1 vacant orbital, this for that vacant orbital. Okay, so whenever the vacant orbital is containing any neutral species or ionic species, act as a Lewis acid. So this carbocation or act as a Lewis acid. Okay, and also it behaves as a electrophile. Okay, more always is covered in this video for that carbocation. If you like this video, you can subscribe and share your friends. Okay, thank you to all.